All right, great. This will be a talk about penetration testing. I gave this talk at LISA, Linux System Administration Conference, last fall. And I had a follow-up last week, actually, at a conference called OpenStack in Vancouver. So I updated these slides recently to incorporate what I did in Vancouver. Basically to tap network as it goes through the cloud. So I'll talk a little bit about that as well. So I'm Dan Lambright. I work at Red Hat in Westford, in Mass. And I also teach at UMass Lowell as an adjunct professor, where I do intrusion detection. Actually, I do storage at Red Hat. So in this talk, we'll be discussing how to do penetration testing on the cloud. And because the cloud is sometimes seen by people who are not in the cloud day to day as a hazy subject, I'll just define what I mean by that. What I mean by that is it's self-service thing, so you can, on demand, you can yourself go and provision instances. Those instances are probably shared, they're virtual, or they're containers. Access is metered, so you're paying by the hour, potentially, or by the resource. And it's elastic. It can easily, because it's virtual, it can easily grow and shrink. So that's what I mean when I say the cloud. The cloud is kind of a big area as well, so there's different points of view when you talk about the cloud. There's the public cloud. This is the one that Amazon, Azure, Google sell access to. That's one type of cloud, and we'll spend part of the lecture discussing it. There's the private cloud. That's when you are the owner of a infrastructure, like perhaps you own OpenStack servers, and you manage them, so you might want to do penetration testing in that environment. And then a third is when you're a tenant in a private cloud where you've been given some special permission to do penetration testing. So maybe above and beyond what the public clouds give you. So what is penetration testing? So this is a security conference, I'm sure you guys know this, so I'll go through it relatively quickly. But what basically you're doing in penetration testing is you're mimicking real attacks. You're testing your security process and procedures, and you're stressing your infrastructure, looking for holes, looking to see where it breaks, and looking to see where your weak points are. You should comment. Good practices are to have postmortems after you do penetration testing, discuss, what went wrong. You shouldn't blame any one individual. Look at it as a learning experience, and you should also expect problems. There's a concept that you'll never get to 100% security. That's a school of thought. I agree with that school of thought. That you'll never get a 100% secure, but you might get, and the question is the number of 9, so you're going to be 99.999 something secure. You can unit test your IPS or your firewall rules. Those are intrusion detection systems are made up of lots and lots and lots of, typically are made up of lots of very, very particular rules that can become very complicated. And same with firewalls. So you can look for holes in them. And those are just some examples of some rule-based systems that you might want to run penetration testing against to look for problems. So tools for penetration testing. Again, this is a security conference. I'm sure you're all familiar with these. Nmap is good, reconnaissance tool. EtherCap is good for man-in-the-middle attacks. HPing3 is a good general purpose. By the way, these are all mostly, for the most part, I'm in a Linux world here. TCP replay can take PCAP files and replay them. So if you have a good attack that somebody captured or that you found off the internet because they're available, you can replay them against your against your systems. It will, TC replay also can change all the IP addresses, so it'll go against your machines, not the original ones. So I'll just go through these quickly because I'm sure you know these all, but these are representative attacks that are sort of the canonical ones. They're good because they're in the core IP protocol. We're stuck with them. IPv4 was not invented with security in mind, so they had these built into the protocols, and we live with them to this day. Spoofing is just changing your source IP address so that it looks like the IP packet came from somewhere else. The internet provider or the router in the internet may or may not block a spoofing attack. It's their choice. There's no rule that says they must. Man-in-the-middle attack is just when you capture a router and you see packets as they go through, and of course authentication and encryption can prevent that, but not everybody uses authentication and encryption. Denial of service is simply where you go after some resource on the target, and that can be any resource, CPU, memory, time, etc. Port scans are looking for open ports on the target. All right, so public cloud security. Let's get to the heart of the talk. So, public cloud. Well, basically public clouds are huge data centers in different regions for geographical reasons. As they're so big, they have some resiliency to denial of service attacks. Let's see, so you cannot spoof your IP address from within the cloud because typically they have a firewall over your instances or your tenant, which stop that. You have no access to physical wires, so you can't sniff other tenants' traffic. But the key, so there are some things that the public cloud gives you, but the provider will not take responsibility for protecting your instance. That's still your responsibility that you have to. So as a tenant administrator in a cloud, for the instances that you administrate, that's your job to protect. The main thing you need to know for the public cloud is if you do a penetration test, you cannot affect other instances or tenants. So any penetration test, any simulation of a real attack that was to affect someone else is, for the most part, not allowed. Though there are some exceptions, which I'll bring up in a moment. They could be expensive to do as well. If you, for example, have spent the money to get a cordoned off part of Amazon's cloud and you decide to do a denial of service attack, so let's say it won't affect anybody else because you spent the extra money for that. That might still cost you a lot because you're generating a lot of network traffic potentially, or CPU. You're not going to be able to install a hardware appliance in the cloud, obviously, and you don't have any low-level access or something like Grub. That doesn't, it's not going to be available to you. IP addresses are ephemeral, and some other items in the cloud are also ephemeral, so that means if you stop the cloud, start it up again, you might end up with some changes that you have to revisit your firewall or IPS rules to change. Those are just some considerations. It is possible to go and get permission from the cloud providers, for the most part, to do penetration tests. They will give it to you and they have different policies. So depending on the provider, they will have different rules. Amazon, for example, will get back to you relatively quickly, and they will, depending on your level of service, allow you to do certain things. I don't think they let you do any denial of service attacks, but they'll let you do other sorts of attacks. You have to explain what you want to do, and you have to say when you want to do it. Some providers have developed a reputation for not responding to you quickly with penetration tests. It went with requests for penetration tests, but they're getting better because they see the importance of it. There are commercial tools you can purchase too in the cloud. Some really interesting ones that I found are ones that have already made the arrangement with the cloud provider, so you just spend a little money and they'll they'll do the penetration test for you. Another one that's kind of interesting, we said earlier the cloud is elastic. Well, it's very easy to add resources. And with this Prolexic, I believe the name is, they will, if you have a denial of service attack, they will, on demand at the time of the attack, give you more resources so you can swallow up all those DOS packets. And these are costly options. So that's pretty much the story with the public cloud. So let's dig a little deeper, and let's say you're an administrator of a private cloud. So let's say you have OpenStack or CloudStack or one of those in your data center, and you're setting it up, and you want to do you want your tenants maybe to do penetration testing, or you want to do it yourself. Well, here the situation's much different because you have access to all the guts and internals of the network. But you still have some considerations. You don't want to affect other instances. If you're doing penetration testing on one tenant, you don't want to affect other tenants, probably. You will probably want to have the ability to observe instance traffic, and that's been a key problem. Because how do you actually accomplish that is tricky. You might want to run IDS against an instance or a tenant, or maybe the entire cloud itself. That is possible. This is sometimes called IDS as a service. I have not seen in open source an IDS as a service, but it's coming soon. We have the pieces in place to make it happen. So here's what OpenStack looks like internally. The green circles are instances. The squares beneath them are firewalls. Notice there's a firewall for each instance. Those are actually Linux bridges. Actually, all these blue squares are bridges. They're software bridges. And these lines are pipes between the bridges. This one called br-int is called the integration bridge. And that often uses something called OVS switch, which is a real cool technology. So as you can see, I guess the takeaway here for a security audience would be that there is a firewall for each instance. And that's not controlled by the instance owner or even the tenant owner. Although they can create security groups which are applied to that firewall, they don't actually can touch and feel that Linux bridge itself. So ultimately, the firewall for the instance is controlled by the provider, not the tenant administrator. So how would you go about sniffing a cloud? Since it's our cloud, we have the ability to make modifications to the infrastructure. It's something we can't do in Amazon. So what you want to do, and for any services that Amazon provides, they would be doing something under the hood similar to this, is create what's called a tap. And a tap is a sniffer. A tap sniffs packets. A good place to sniff at the tenant level probably would be at the integration bridge. You could also put a tap at the firewall, but then you'd be sniffing just that instance, which might be an acceptable use case for you. But if you do it at the integration bridge, you can see all the traffic, and if you look at the VLAN tag, so each tenant has its own tag, VLAN tag, which will tell you what tenant it belongs to, then you can look to see all the packets for that tenant. So here, at a high level, I've done a tap to the integration bridge and connected it to an intrusion detection system. In practice, here's how you can accomplish that. Now, I'm going to show you a hack, but I'll tell you the right way to do that is probably something that's called tap as a service, which for OpenStack, which is something that just recently appeared from I think Ericsson's designing it, but some other people are very interested in this. I'm going to show you a way to do it. Actually, I'll just fly through this because actually I'm not sure at this level of detail might be a little high, too much in the weeds. But basically, I'm going to the instance. I'm attaching another interface to it. That creates a firewall. And that creates two interfaces, one connected to the instance and one connected to the integration bridge. And what the problem with that is it creates a firewall, which I don't want. So what I can do, let me go back, see if I can, here we go. So what I can do is I can destroy the firewall, because I don't want it, and attach the new interface, which I just created a moment ago on the previous slide, directly to the integration bridge, using those commands. Now, to do the tap, I'm using OVS virtual switch. That's the networking bridge technology which OpenStack uses. And you can create a mirror using that long and ugly command. Typical Linux world, you have long, ugly commands. I guess for you folks, it's probably not unnecessary to see this level of detail, but here's how you do it. All right. So, all right. Let's go back up to the high level now, and we can point out another factor at an architectural level. Is your IDS, your sniffer, could live on the same node, but the problem is if you've spun up a virtual machine, which is running an IDS instance, then the virtual cores which run that come out of your budget. So you're expending some of your virtual core budget you're burning some of that for your IDS, and that can get that can take away from your normal instances. And if you're fanning in traffic to that IDS, it can consume a lot of CPU. And remember, when an IDS drops any packet, that can be a false negative. That can you might think the traffic is okay when it's really not. So how can you avoid that? Well, you can have a tunnel which goes to a monitor node, and the characteristics of this node in the cloud can be different. It can basically throw more hardware at the problem. I have a bunch of slides where I just describe how to do this, but that's way in the weeds. Just at a high level, though, in the cloud, if you're going to do some pen testing, these are some options for you. All right. So that is if you are the administrator of the cloud. Let's say you're a tenant administrator. I'm a tenant administrator, and let's say that your cloud provider, probably your private cloud provider, but perhaps you have some arrangement with Amazon, which is above and beyond what I believe to give you. How would you go about penetration testing inside of an instance? So this is the third use case. If we're doing penetration testing, a key thing is we don't want to affect other instances. I don't want to put any of this hacker traffic on my network. And then there's some penetration tests which you simply cannot do, because remember, you can't do spoofing from inside the instance. So if I'm running inside of an instance, how can I do penetration testing? Well, what I've successfully done is spin up a container and do the penetration testing from the container. Now, you can also run, actually, a virtual machine inside of a virtual machine. But containers are what I'll talk about, because they're so much easier to work with. If you haven't worked with containers before, I strongly recommend it. When you can create a container or a virtual machine, you get your own IP address. In fact, you get your own subnet, so you can create multiple containers, and they'll all speak to each other on the same subnet. They have their own MTU, which you can actually modify. So you can send big packets if you want. And now, an interesting thing about containers is they give you a ceiling on how much resources a container can take. They're actually, in the Linux world, they're called a process group. And you can say, well, you'll get only this much in that process group, only this much horsepower, memory, etc. But interestingly, there's no floor on resources. So there's no minimum amount of resources that they're guaranteed to get. It's just something to be aware of. By taking this approach, you're not going to test your external firewall. You're only testing within the instance itself. So, if you're going to use containers, and actually a lot of this applies to nested virtualization as well, what you're going to get, remember this picture, this is our virtual machine, that's our instance. This is the external firewall, and that's the integration bridge that connects to the rest of the universe. What you're going to do inside the instance is you're going to create a container up there. That's the purple machine. Now I can run Kali. That's a Linux distribution which is great for penetration testing. It's pre-built Linux with a lot of the tools. And when you create the container, you get actually a bridge, another Linux bridge. But it's a bridge inside of this instance. So that takes literally seconds to set up. It's very simple to create. Another nice thing that containers give you is, Kali runs on Debian, and I usually run on CentOS or RHEL, and works fine. You can import PCAP files into your container. Now, I would love to do a demo, but I haven't set up for it, so what I've got is a simulation here. Basically shows the same thing. So I can easily run from inside that container nmap against my instance. And here I ran snort. Here I ran snort on my instance. Packet came in, and you can see the Christmas scan was caught. So nmap is pre-built in Kali. So that was a reconnaissance attack, which I did from the container. I can do a spoofing attack from the container too. Since I'm running inside the instance, and I control the Linux bridge, and I control the container, there's nobody to stop me from doing a spoofing attack, as there is from the external firewall. So here I'm running hping. That's a Linux utility to simulate. I think it runs on Windows too. To say my source address is 22.22.22.22. I think, yeah. And I'm sending. I don't forget what the -s does, but you can see that the packet arrived, and you can see the source address is 22.22.22.22. So I've successfully executed the spoofing attack from the container, and I can exercise my IPS rules that way. Man in the middle. Man in the middle is a little harder, but still possible. So a nice tool to do man in the middle attacks is called EtherCap in the Linux world. But you need to have 3 players now: the target, the attacker, and the man in the middle person. So you basically need 2 containers. So I created a second container right here. Now, this is really kind of interesting, because what EtherCap does is it poisons the ARP tables of the, I guess the victim would be Docker 1 in this case. So the victim's ARP tables are made to think that this instance's IP addresses are real. The ARP address for this guy is this guy. So therefore, this is one way to do man-in-the-middle attacks, is by ARP poisoning, by changing the ARP tables to mix up the IP addresses with the ARP addresses. So I do that with EtherCap, and in so doing, packets intended for the green host instance actually end up first to him, and then they're forwarded to the ultimate destination. When they arrive at Docker 2, they can be changed. They can be expected or modified. So you can execute the man-in-the-middle attack. If you haven't seen either cap, it's a great way to do penetration testing for man-in-the-middle attacks. Denial of service. For denial of service attacks, well, that's an interesting subject because this is a resource attack, and I said a moment ago that there's a cap on the amount of resources Docker has. So you really can't do a true denial of service attack. And in fact, denial of service attacks inside the cloud are an interesting subject by themselves because how many resources do you have in the cloud, and can you affect other tenants and so on and so forth? It's an interesting subject. So I'm not sure, I don't think I can make a claim that you can actually execute a true denial of service attack, but you can simulate one and test your rules, which is still a very useful thing. So I'm using hping3 for that, and here I've executed a few different types of denial of service attacks, and I've exercised my rules. Still very useful. All right, well, this is just an example to show that you can do any attack. So here's a more recent one. I'm doing the shell-shocked attack. I don't know if you know shell-shocked, but there's a bug in the bash shell which has a hole, basically. So let's see here. All right. So in summary, because that's basically brings an end to my talk, and then I take questions if you have any. You need to coordinate with your cloud service provider because in penetration testings are a sensitive subject. You're simulating a hacker, but cloud providers do give you some level of access. Actually, everything up to denial of service attacks. Typically, I think you can get permission to do. OpenStack is a work in progress. They do not have IDS as a service yet, but it is possible if you're technically up to it, willing, to set up sniffers to sniff packets. And for unit testing your rules for penetration testing, I would recommend Docker. It's not the only way to skin the cat, but it's a good way to do it. I found it to be very simple to use and took me 90% of where I wanted to go. All right. Thank you. That's it. You're doing penetration tests in the first place, so you're already going a little bit beyond the typical user. I think it basically boils down to that. If you're not root user, you probably cannot do this, but if you're the tenant administrator, which is really my audience, would be the administrator of the tenants, you probably have root user to, you probably have root user if you're the tenant administrator. So basically, I didn't tackle the use case where you're not root user.
Yeah. So you showed us that we should create a tab. So what kind of privileges would you require for that? Because doing a penetration test, you might not have all the privileges. To create a tab, you might need to be an administrator. Same thing for the doctor and the dentist. So kind of on the same lines, but doing a penetration test, you might not always have. Even the administrator might even not know that you're doing a pen test. How would you tackle it?
I haven't really thought about it. If you don't have root privileges, then there's just so much you cannot do. But let me go back to the Docker case. Let's see. So if you're not root user, well, you can create Docker containers. So if I'm a normal user, I can create a Docker container. So that you load Kali into the Docker container, I believe. Is that true? So, I mean, I will be able to send packets from the Kali Linux container to myself. Now, when would you need privilege? If I remember right, you need privilege in the Docker container for when you're monkeying with, say, /proc files or some such like that. I only needed to do that in my recollection when I did man-in-the-middle attacks, EtherCap. So, I mean, I'd have to rerun these tests as a non-admit root user, but I suspect it's possible to do if you're, maybe not all the tests, but some subset of them. Yeah.
So I have a follow-up question to that. So basically on the public cloud, you said tenants cannot send messages to each other. Like on the public cloud, two instances cannot talk to each other, right? On the private network, obviously. So how would you do a pen test when you cannot send package to another instance?
Well, inside of an instance, I can check IPS rules or IDS rules, firewall rules. I cannot send a packet to another instance. That's true.
Would you have access to the instance in a normal pen test?
No. No. You would. You mean so? If you're let's say you're a tenant administrator, and there's two instances. If I'm a tenant administrator, I assume a priori that I have access to like the PEM files for those users, and I can sign into them and get in as root user. So in that case, I can send packets from one instance to another. That is possible, but they might be blocked by that firewall. But if I'm the tenant administrator, I can modify that firewall too. This is the OpenStack use case where, as a tenant administrator, I might have some abilities. Yeah. So, I mean, cloud is very hard because you got three situations. You got the public cloud where you have almost no access to the guts of the networking. You have the private cloud where you might have access to the guts or you might not. And then you have the pure where you're just an instance owner and you have no access to anything, which is, I think, and not root user too, which is, I think, the use case you're talking about. And I haven't gone to that minimal level of privileges, but I think you're probably limited. Any other questions? All right then. Thanks.